All right, welcome everybody. So today we're going to talk about a very specific data type in Python that's going to be pretty useful for us moving forward in our data analysis projects is a library called Numpy. And so Numpy stands for numeric Python, but before we get into Numpy properly, I do want to talk about something that I had in the lecture from Tuesday, which is importing libraries. So again, we talked about this already, but libraries give us kind of extended functionality in Python. So the core of Python has a limited functionality, and all of these libraries give us expanded functionality. Okay? And the reason that these aren't kind of included by default is that when you write a program, basically, by using these import statements, you're adding just the functionality you need. Rather than it being a big bloated program with way too much stuff that you're not using, it gives you the kind of fine control to just import the libraries that you need. And so the way that we import commands is with the import function. So we just type import and then the name of the library that we want to import. Okay, and so you do have to know the name of the library that you're trying to import, but you can usually find that through searching on Google or searching through the Python libraries online, the lists that we've talked about. And so this is kind of the most basic way to import a library. Okay, so we'd say import the name of the library. Okay, so import datetime in this case. So datetime is a library to do has a lot of date time functionality, since dates and times are kind of weird in terms of math operations and things like that. So there's a whole library for that. We talked about the math library already, and then the one that we're going to use today again is NumPy. So we can say import NumPy. Okay. And so over in my console, okay, now that I've imported those libraries, I can go in and say NumPy dot. Okay, and then I'm going to hit my tab key to get the list of functions that are associated with this library. Okay, and that's a huge long list. Okay, so that's at the very basic way to import a library. Now, in Python and a lot of programming languages, as you're typing code, the number of keystrokes starts to add up. So the number of characters you're actually typing starts to add up. And so one way that we can kind of streamline our coding as we go is to start to we call alias certain libraries. Okay, so we can actually tell Python that we want to call the datetime library something else. Okay, and so if we want to do that, and this is generally a good idea, is to say import datetime in this case as, and then whatever kind of variable holder name you want to give it. Okay, and so usually we just start with abbreviations of the library. So datetime we could abbreviate as DT. The two below it are the ones that we're going to use a lot for our data analysis, are NumPy. So NumPy as NP, so N and P for NumPy. Okay, that makes a certain amount of sense. And another one that we'll use quite a bit is pandas. Okay, and pandas we usually import as PD. Okay, so if we import NumPy as NP here, okay, now instead of having to type out NumPy dot to get the functions that we need, okay, all we have to do is say NP dot, and one that we'll use quite a bit is the array function. So ARA. There we go. Okay, so the np.array is to build an array. Okay, that's one of our core functionalities. And so by just abbreviating to np, we've saved ourselves, in this case, 3 keystrokes. Okay, and so 3 keystrokes over an entire program or in an entire data analysis run saves you a lot of typing. Okay. The last thing that we can do with importing is to just import a specific part of a library. Okay. Some of the libraries are gigantic, and if you tried to import the whole thing, it would make it pretty cumbersome to actually get to the functionality you need. Okay. So one example of this is the matplotlib library. Okay, this is for generic kind of graphing tasks and some image processing tasks. But in our case, if we just want to make a simple graph or a simple series of graphs, we don't want to import the whole library per se. We just want to import a small subsection called pyplot. Okay, and so the way that we can do this is just saying from the library that we want to import, matplotlib, we want to import just a section. So just the pyplot section. And then, like we did above, we can abbreviate that as PLT for plot. Okay. And so down here, we'll talk about how these work in just a second. But basically what I'm going to do is just to show you how this works. Okay, we're going to do an X range, which is just a series of X values from 0 to 20 in steps of 0.1. And then I'm going to create some Y values for our graph by taking the sign of those X range values. Okay, so if I run that, okay, we get, oh, need to import the whole thing. Okay, so import that. I'm going to get two arrays, so you can see those in my variable explorer here. So this is just a list of numbers, okay, and then the results of the math equation that we use, the sign function. And then we're going to use this bottom one, plt.plot creates a line graph with the X values that we want to plot and the Y values that we want to plot. Okay. And what pops up is a basic graph of the sign of our X values. Okay, so that creates a classic sine wave plot. So onto Numpy properly. Okay, and so this is the week 2-2 lecture notes. So let's talk about what an array is. Okay, so an array in Python is a container for data. Now we've talked about lists, and arrays you can think about like more complicated lists. Okay, the default list variable type in Python is pretty limited in what it can do. Once we start to move into NumPy arrays, there's a lot more functionality that NumPy has to do math and manipulation and things like sorting and, merging arrays together. There's a lot more functionality built into NumPy than the default list variable type. So generally what I say to a lot of people is that, lists can be used for very specific things in Python, but for the most part, I substitute an array anytime I would use a list. Okay, it just extends the functionality a little bit further and I can do more stuff with it. So an array can come in what we call different dimensions. Okay, and we'll look at these in just a second, but I'll explain what they are. So arrays have different dimensions. So this is basically the number of cells in the array. So if you want to think about an array kind of like a Microsoft Excel or Google Sheets spreadsheet, that's kind of the best way to think about these. Okay. And so in NumPy, we have three different ways we can arrange data. Okay, and the first is what we call a one-dimensional array. And essentially what a one-dimensional array is just a single row in our Excel table. Okay, so if we just take the top row, we have a single data type, let's say temperature or river discharge or whatever. Okay, we just have a series of values in kind of one row of our Excel sheet. And that's what a one-dimensional array is. Okay, there's just one row. If we wanted to add more rows to that, okay, so that we would have basically something that looks more like an Excel sheet that has rows and columns, then that becomes what's called a two-dimensional array. Okay, so rows and columns are the two dimensions. And then there's a third type of array that I'm going to be honest, you're not going to use that often, is what's called a three-dimensional array. And you can actually get 4 and 5 and 6 dimensional arrays, but those get very, very complicated very quick. So let's stick with a three-dimensional array, okay, is the idea that we would have rows and columns, but then we could actually have multiple, if you want to think about it in Excel terms, multiple sheets in our file. So we could have rows and columns in sheet 1, and that would be a two-dimensional array in sheet 1, and then we could add another two-dimensional sheet or two-dimensional array in sheet 2, and that would be into the what we call the depth of the array, so into the third dimension. So let's look at what that actually looks like here real quick. Okay, so I've got this open in Excel, and just to kind of illustrate how these kind of look differently fundamentally. Okay, so if we take a one-dimensional array here, again, this is just essentially just a list of values. So nothing too special about this. Okay, just a singular list of values. Once we start getting into the 2D array realm, okay, this is again where we start to get rows and columns. Okay, and again, most of the data that you're going to encounter out in the world for data analysis is probably going to be in some two-dimensional format. Okay, so a lot of you have played with GIS data. Okay, a lot of GIS data comes in two-dimensional form. Okay, so you'd have, you know, your rows would be different features and your columns would be different attributes. Okay, other data that comes in two-dimensional kind of default styling is, you know, a lot of the environmental data that we'll look at on the web. So things, you know, even something as simple as a temperature record, okay, would have two dimensions to it, because we'd have a column for, say, the dates and times, and then another column for the data. Okay, so in that case, we'd just have, you know, we'd have two columns and multiple rows. Okay, or if you're downloading kind of weather data more broadly, you'd have dates in the first column, temperature in the second column, wind speeds in the third column, precipitation amounts in the fourth column, well, on and on and on. Okay, so two-dimensional arrays are the pretty much the most common type of data that you're going to find. Like I said, three-dimensional arrays become complicated. Okay, and essentially these are, like I said, kind of two-dimensional arrays that are kind of stacked on top of each other. So in this case, we have rows and columns for each layer, and then we have multiple layers that go back. Okay, and the place that you're going to see this most commonly is in images. Okay, so if you've taken a remote sensing class or a GIS class, okay, you know that a lot of imagery that we would look at has three bands to it, okay, or three different layers to it. So would be, in most cases, that's a red, a green, and a blue layer that would combine to make a natural color image. And in those cases, okay, we have each of the bands of that image, or each color layer in that image, is a two-dimensional array of pixel values. Okay, so you have a blue pixel values, an array of blue pixel values, an array of green pixel values, and an array of red pixel values, but they're all kind of mashed together into one variable or data container. Okay. So again, we'll get to three-dimensional arrays a little bit more later on once we get into image processing, but generally you're not going to use three-dimensional arrays that often. Okay, so we'll talk about this a little bit more in depth, but I just want to introduce it to you guys now, is the idea of array indexing. Okay, so we talked about indexes for strings and for lists, and array indexing follows the same conventions. So in the case of a one-dimensional array, okay, the first value, okay, we can refer to that by its position, okay, and so the first value in that array, or the first cell in that array, is the 0 cell, okay, and then the second one would be the 1 cell, the third one would be the 2 cell, the third one would be the 3 cell, fourth would be the 5th cell, or no, the 5th cell would be the 4th index, and then in this case the 6th cell would be the 5th index, or would have an index of 5. Okay, so start at 0 and count up. Okay, in a two-dimensional array, okay, we actually start to use the row numbers and the column numbers almost like coordinates to find the cells that we need. Okay, and so we do this in a fashion that is row first and then column. Okay, so if we look at this first cell in our array here, this is the 0, 0 cell. Okay, so the row number is 0, the column number is 0, and so that's 0, 0. Okay, if we go down to, say, this one right here that I've got highlighted, okay, this is in the third, it's in the, technically in the fourth row, but it's the index 3 row, okay, and then it's in the index 1 column. Okay, so third row, or row 3, column 1. Okay, and so you'll hear me say this throughout the semester. I'll refer to this as row 3, okay, but that's with the explicit kind of understanding that there is a row 0 as well. Okay, so 0, 1, 2, 3. Okay, and then if we go all the way to the far corner here, okay, this is in the 7th row, okay, the 7 index row and the 5 index column. Okay, so we refer to that cell as the 7, 5 cell. Okay. And just to kind of complete the trifecta of array types, okay, with 3-dimensional arrays, okay, we kind of take the 2-dimensional array convention and just add the depth to it. Okay, so we'd say row, column, and depth as our index values. Okay, so like if I looked at this cell right here, this is in the 0 depth array, okay, but it's in row 7, column 3, and on the first kind of sheet, okay, so the 0 sheet. If we went back, okay, we'd change that last number to the 1 sheet or the 2 sheet or however many sheets go back into our 3-dimensional array there. Okay, so we'll look more at this in just a minute. So, like I just talked about, the recommended way to import NumPy is with import NumPy as NP. Okay, that's the way the NumPy documentation will always do it. So whenever you see NP in the NumPy documentation, it's referring to its core library. Okay. So the way that we construct arrays, okay, you can construct arrays by hand. We'll talk next week about importing data directly into an array, or more specifically into pandas data frames generally, which are like more advanced arrays. But we can build these arrays up by hand, okay? And so the way that this works is that we build these up as individual rows, okay? And so if we wanted to build up a one-dimensional array, so I'm just going to call this 1D, we say np.array, okay? And then to specify the row, in this case, we're just going to have one row since it's a one-dimensional array. But for our kind of row start and stop kind of characters here, we're going to use these open and close brackets. Okay? So in this case, we're going to say np.array, an open parentheses, and then an open bracket to indicate that we want our first row. And then we can just type in our numbers. So 1, 2, 3, 4, 5. We're done with that row, so we're going to use a close bracket, and then in this case just a close parentheses since we just want one row of data. Okay. So if we run that, okay, you can see that that now has produced an array. Okay, so this has a new data type that we haven't seen yet, an array. Okay, and the other interesting thing that at least Spider will do for us is actually tell us what the data types in that array are. Okay, so this is an array of integer values, so an array of int values. Okay, and so you can see the values over here, 0, 1, 2, 3, 4, 5, like we typed out. And the beautiful thing that Spider allows us to do, okay, is if you double click on those values, okay, it'll actually pop up a new window that'll actually show you the array kind of as it exists in memory. And this will be important later on when we get into two-dimensional arrays, and definitely when we get into pandas data frames. But so here you can see we have, this shows up as a column, but it is a row. It's a little bit of a strange Spider quirk, but we just have kind of one row of data, so it shows up here as just one row. Okay. You can print an array just like you can any other variable, okay? And it'll print out over in your console kind of as you typed it in. So it'll have the bracket to indicate the row, the values, and then an end bracket to indicate the end of a row. Okay. So one thing that you're going to probably want to do quite a bit once you start importing large data sets is know how big that array is. Okay, because that's something that we'll talk about when we get into array math, is that oftentimes you need to make sure that your arrays have similar sizes, okay, or similar rows or similar column counts. And so one way to do that is to use what we call the length command, okay, the length function. So you can ask Python, what is the length of an array? Okay, and this will tell you that it's 6. Okay, so there are six slots or 6 values in it. Okay. Another thing that you might be interested in is how many dimensions are in an array. Okay, and so this is something that's relatively new for us, is that we can actually start to call methods on a variable. Okay, so Python or Numpy has kind of imbued this variable, in our case 1 underscore d, okay, is our array. We can actually get to certain properties of that directly from the variable. Okay, so in this case I can say 1 underscore t or 1 underscore d dot, and then there's a series of kind of additional functions that are kind of, or properties that we can access as part of that array. Okay, so one of them is what's called the number of dimensions. Okay, so ndim is number of dimensions. So in this case, if I print that, okay, I'm just going to get 1. Okay, this is a one-dimensional array. That's easy. The other one that actually does the same thing that length does, but in a more explicit way, okay, is to do 1d.size, okay, and that'll give us the size in terms of the rows and columns of an array. Okay, so if I print that, in this case it's just going to say 6 because there's just 6 values in a one-dimensional array. We'll look at what a two-dimensional array spits out here in just a second. So if we wanted to build up a two-dimensional array by hand, okay, we just use the same kind of syntax that we used above. Okay, so we say a two-dimensional array equals np.array. And in this case, since we want to have multiple rows, okay, we're going to actually put a bracket around, an open close bracket around the entire array. And then we use open close brackets inside to indicate the rows. Okay, so 1, 2, 3, 4 would be row 1. Okay, and then we'd say close bracket, comma, open bracket for the next row, 5, 6, 7, 8. Okay, close bracket, and then another close bracket for the entire array. Okay, so if we run that, now you can see up here, okay, we have a two-dimensional or 2D variable. Okay, it's an array of integer types. Okay, but now here you can see the size is 2 rows by 4 columns. Okay, so this is one place we can check the size of an array. And if we double click on this, you can see this starts to look like that Excel example that I showed you. Okay, so we have, and Spider will actually show you the row and column index values. So 0, 1, 2, 3 are the index values. So this would be 0, 0. This would be 1, 1. This is 0, 3. Okay, so this is a way to kind of help you learn how to do these indices properly as well. Okay. Kind of on the topic of line continuations that we talked about at the end of class on Tuesday, we can actually, if you hit return after the comma in your different rows, you can actually start to make it look, at least in your code, like it's going to build up properly once you run that. Okay, so in this case, we're going to make three rows by 4 columns. Okay, so np.array, open parentheses, open bracket, and then another open bracket for our first row. Our first row of data, close bracket, comma, and then we just hit enter on our return on your keyboard. Okay, that'll pop us down here automatically. Do another open bracket, our second row of data, close bracket, comma, enter, and then we get to the third row, okay, and you could keep going for as many rows as you wanted to build up. Like I said, once we get into data import and export, this will become a lot easier and you won't have to do it by hand, but there are a lot of tasks where you will have to create arrays by hand because you'll use them over and over again in your code. Okay. So in this case, I'm going to overwrite my 2D variable here. Okay, so now we have we call a 3x4 array. Okay, so 3 columns by 4 rows. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, just like we typed it in there. Okay. And so here we can start to look at, again, those kind of properties. So we can ask Python what the number of dimensions are. Okay, in this case, it's returned 2 over in our console. So it's got 2 dimensions, rows and columns. And then the other one that we can get here is the shape. Okay, so if we do our array.shape, it'll give us the values for the rows and the columns. Okay, so in this case is a 3 rows by 4 columns array. Okay, these values in themselves, okay, can be indexed separately as well. Okay, and so this is something that I use a lot in my code. Okay, is that if you just want the number of rows, okay, this is essentially a list. Okay, it's a special kind of list called a tuple, but we're not going to worry about that. Okay, but this output is essentially a list. So the first value here, 3, has a 0 index, and the second value, 4, has a 1 index. Okay, so in this case, if you want to pull out the rows, okay, you'd say your array.shape, and then you can do an open bracket for the index, the 0 index, close bracket, and that'll just give us the rows. Okay, and then same thing for the columns. Okay, but we're going to use the 1 index here. So now you can see in our variable explorer, we've got a rows variable with a value of 3 and a columns variable with a value of 4. Okay, so that's an easy way to pull those data out. So one of the questions that often comes up is why we use arrays rather than lists or some other data type. And the simple truth of the matter is that arrays are just faster. Okay, so once we're doing math on arrays, it just is so much faster than the default Python list. Okay, and so just to kind of prove it to you, okay, there's a specific library called Timeit, which does it's for kind of pre-processing of code or code testing to tell us how fast like a function is going to run. So in this case, we're going to look at an array. Okay, and so we'll look at how to create an array like this. Okay, but this is going to be an array of a one-dimensional array with 10,000 variables. Okay, so from 1 to 10,000. Oh, I mistyped there. Okay, so just there, I created you can see it up here. I just, with that one line of code, very quickly, I've created an array with values from 0, 1, 2, 3, all the way to 9,999. Okay, and if we run this function, okay, here, so what we're going to do here, okay, is we're going to use what's called the Timeit function to test how fast we can basically add 1 to each of those values in that array. Okay, so we're going to turn 0 into 1, 1 into 2, all the way to the last value. Okay, so if I run this, okay, Python will take a second to think about it. Okay, and it's actually running kind of several iterations of the same kind of function. Okay, and what it spits out here is that we get an average time per loop, so per addition, okay, from the different iterations that it did, okay, of 5.23 microseconds to do those calculations. Okay, so our array of 10,000 values, if we wanted to add 1 to each of those values, okay, with Numpy, it runs at an average time of 5.23 microseconds. if we do the same thing over here with a traditional Python list, okay, we can see how long this takes to run. And so in this case, this is running to do the same, essentially the same operation. So add 1 to each value in a traditional Python list. That takes 580 microseconds. Okay, so that's 100 times as much time, okay, to do that operation. Now, we're talking in microseconds here, and that's not potentially that critical for most operations that you're going to do, but it is much, much faster to do it with a Numpy array than it is to do with a traditional Python list. Okay? And especially once you start dealing with large data sets, okay, these microseconds, this difference in microseconds starts to add up. And so using Numpy arrays will make things a lot faster for you. Okay, we're going to leave off for today, for this lecture right there. In the next video, we'll talk about array indexing and a specific type of kind of extraction called slicing. And we'll actually start to get into some math operations as well.